The idea of a black hole can be traced back to the 1700s. Still, in modern times, it starts with the revolutionary theory of gravity by Einstein in 1917, which has served as a foundation for scientists to discover more information about black holes over the years. What becomes a black hole is when a star is dying and the matter is squeezed into a tiny space. This fact defies the law of physics, and it's one of the things that make black holes intriguing. Black holes are generally not visible for people to see because light cannot come out of them. That's why scientists made some special space telescopes used to study how stars that are very close to a black hole act differently from the conventional way stars act. A black hole is where gravity is extreme and not even light can escape. So how does this happen? It's all caused by dying stars. Smaller stars begin to burn out and die for billions of years. They become dense neutron stars. A star at least 3 times larger than our sun dies, creating a supernova explosion. And if it's big enough, it will collapse in on itself from the force of gravity, and a supernova explosion lasts just about 100 seconds. Stars between 8 and 50 times the mass of our sun exhaust their hydrogen core over millions of years, but it takes just seconds for them to collapse. As the star collapses, it reaches a certain point called the event horizon, and time on the star slows down. When it reaches the event horizon, it can't collapse anymore, and the end of the star is the birth of the black hole. Now let's talk about the terrifying truths about black holes. If you passed the event horizon, gravity would be so strong that you would be stretched out violently by the gravity field into a one-molecule wide string. Also known as the noodle effect, it's when things are stretched into long, thin shapes like spaghetti because of powerful gravitational forces. While this may sound funny, it's not something you want to happen to you or anyone. Scientists are hotly debating what would happen if you fell into a black hole. Long story short, your body would be infinitely stretched as it gets pulled closer and closer to the center of the black hole. Your body will be kept together, but stretched until you reach atomic levels of fineness, and for you, time would begin to stand still because you would be moving at the speed of light or something like it. But someone who's on the outside looking in, they have a much different view of what's going on. Remember, it was mentioned that light doesn't escape a black hole, so of course, no one can really view what's happening inside a black hole. But to the outside viewer, the person getting spaghettified wouldn't look that way. They would see the last possible image of the person who had just crossed over into the black hole's gravitational field. That image would remain for some time until it would eventually change color and vanish with no sign of spaghettification because it would all happen so fast. Any object molecules that are pulled into the gravitational field of the black hole would be ripped to shreds. As if black holes weren't already super abstract and difficult to understand, there's a huge mystery with black holes. Quantum physics theory states that information can never disappear, so your atoms would be rearranged, but in theory, you would be able to see those atoms and tell that they were once part of a human. But if a black hole evaporates, as Stephen Hawking showed, then everything vanishes with it. Another confusing aspect is that the core of a black hole is infinitely small, yet has infinite mass. What's more, time and space bend around the core, so time actually slows down and space is literally swallowed into it. This begs the question, what is happening inside a black hole's core? The debate and the theories continue. It's mysteriously terrifying. Black holes produce a lot of energy. It has to do with the event horizon of the black hole. The closer the things get to the event horizon, the faster things move as the gravitational force gets stronger. As all the material gathers around the event horizon and starts orbiting around, it gets faster and faster. Because of the speed, it heats up and it gets really hot, like billions of degrees Fahrenheit hot. Things actually act differently at this temperature. This extreme heat transforms the mass from the material into black body radiation, which is a form of energy. Now this is significant for the following reason. Here on Earth, our best nuclear fusion process can take 0.7% of the mass and turn it into energy. Because of how a black hole works, it can convert 10% of the mass into energy. See the difference? In fact, this is so extraordinary in some scientists' minds that they think this radiation and process could be used to power spaceships in the future. Interestingly enough, black holes can also evaporate and disappear over time. Stephen Hawking predicted this discovery in 1974, now called Hawking radiation. It evaporates into space little by little until there's nothing left. Do black holes come in many sizes? Can you believe the smallest ones can be the size of an atom? Even though they may be tiny, they have the mass of a large mountain. Scientists believe that there are many black holes all around the universe, and possibly even on Earth. So why don't we feel them? Well, they're so small and their gravity is so unimpactful that we just don't feel them. However, they don't stop growing. They're far away if you weren't already terrified enough by the thought of black holes dotted around our universe. Yeah, might want to think again. In theory, black holes can grow indefinitely. Yeah, that's right. They just get bigger and bigger and bigger, even larger than supermassive black holes, which are millions of times more massive than our sun. Black holes can be put into 3 classes based on their size. Firstly, a stellar is made from collapsed stars and several small tens of solar mass gradually getting bigger. Secondly, a new category was made in 2014 from middle-class stars of masses anywhere from a few hundred to a few hundreds of thousands of solar masses. Lastly, supermassive formed from stellar clusters and other small black holes, which can be anywhere between hundreds to thousands to 10 billion solar masses. What's crazy about black holes is that they keep growing even past their enormous supermassive status. Scientists have theorized an even larger category of black hole, ultramassive, found at the center of studying galaxies. And these megalithic monsters can theoretically reach the 50 billion solar masses club, after which point some scientists think they get so big that they can't physically grow anymore as they start to disrupt their accretion disks. Black holes are considerably an edge of space. It's a one-way exit door from our universe, meaning anything inside a black hole will never be able to communicate with our universe ever again, even in principle. The main area where scientists' understanding breaks down is the center of the black hole. Time itself comes to a destructive end at the center of a black hole. This is the reason why sometimes a black hole is called the reverse of creation. But no one could explain how or why time ended abruptly at the center of a black hole. New laws of nature must be discovered that will explain exactly what happens at a black hole's center. Some scientists have claimed that the inside of a black hole leads to another universe. Is that true? No one really knows. No principle or direct experiment has discovered what happens at the center of a black hole. That's why scientists need to study and find out from the outside, because the challenge is no one can survive inside. What other interesting things do you know about black holes? Let us know in the comments section below. Be sure to subscribe, and I'll see you next time.